VSEPR, or valence shell electron pair repulsion theory, is the theory that unshared pairs of electrons in bonds or electron groups repel each other so that they will always be as far away as possible from each other. It shows what the molecules would look like in real life or in 3D. The electron geometry is the arrangement of anything around the atom, or how many things are around the atom. The molecular shape is the actual shape of the molecules, taking in the effect the unshared pairs of electrons have on the shape. This is what the molecule will actually look like. Both describe the shape of the molecule. The linear electron geometry occurs when there are two or less electron groups in the molecule. It can occur when there is one electron group and one unshared electron pair, or just two electron groups. The molecular shape is when it will always be linear if the electron geometry is linear, because the electron pair and the electron group will always be as far apart as possible. They are 180 degrees apart. An example of linear electron geometry and molecular shape is silicon-oxygen 2, which would look like this because it has two electron groups coming off of it, which are represented by the pipe cleaners. A linear electron molecular shape could also be shown like this, with this representing an unshared electron pair. Trigonal planar electron geometry is when there's three electron groups arranged around the central atom. All electron groups are as far apart as possible, and because the molecules are three-dimensional, they're 120 degrees apart. It can also happen when there's two electron groups and one unshared electron pair, still having the same electron geometry, but having a different molecular shape. The trigonal planar molecular shape is when there's three electron groups positioned 120 degrees apart from each other around the central atom. An example of this is boron chlorine 3, with three chlorine molecules around the boron. It would look like this in VSEPR. The molecular shape can also be trigonal planar bent, which is when there is two electron groups and one unshared electron pair. Because the electron pair pushes harder against the electron groups, it means that the distance between the electron groups lowers a little bit. This can be shown in nitrogen-oxygen 2, when there's two oxygen molecules around the nitrogen molecule, but the nitrogen molecule also has an unshared electron pair above it. This could be shown like this, with the electron groups a little bit closer together because the electron pair pushes harder, making the angle a little bit less than 120 or about 116 degrees. Tetrahedral electron geometry is when there's four electron groups around the central atom. All the electron groups are as far apart as possible at 109.5 degrees apart. It can also happen when there's three electron groups and one unshared electron pair, or two electron groups and one unshared electron pair. They will all have the same electron geometry, but different molecular shapes though. Tetrahedral molecular shape is when there is four electron groups and zero unshared electron pairs around the central atom. An example of this is nitrogen-hydrogen 4, which can be shown with four hydrogen molecules around one nitrogen atom. This can be shown in VSEPR, the model that looks like this. They're all 109.5 degrees apart. There can also be trigonal pyramidal molecular shape. That is when there's three electron groups or bonds and one unshared electron pair. The shape is different because the unshared electron pair pushes harder against the bonds or electron groups, lowering the distance between the bonds or electron groups from about 109.5 degrees to around 107 degrees. It can be shown with antimony hydrogen 3, with 3 hydrogen molecules around 1 antimony molecule, with 1 unshared electron pair on top. The VSEPR would look like this, with the bent pipe cleaner representing the unshared electron. There can also be a bent molecular shape when there's 2 electron groups or bonds and 2 unshared electron pairs. The shape is again different because the unshared electron pairs push harder against the electron groups or bonds, making the angles smaller. The distance between the bonds or unshared electron pairs is less than 109.5 degrees or about 105 degrees. An example of a bent molecular shape is oxygen fluorine 2, which can be shown with 2 fluorine atoms around 1 oxygen atom with 2 unshared electron pair groups around the oxygen atom. The VSEPR would look like this, with bent pipe cleaners representing the 2 unshared electron pairs. The electron groups or bonds are a little bit smaller than the regular trigonal pyramidal or tetrahedral molecular shapes.